Hello everyone, hope you're doing and welcome back to my channel. Today we are at day 25 of the February Daily Leetcode Challenge, and let me tell you, this is a very nice question. So if you are trying to solve this question, I will request that at least have 1 to 1.5 hours with you, and then try this question. Then you will get the maximum out of this question, okay? Because this is a really good question. This will not look that difficult, okay? If you have solved similar problems, you will like know the trick, okay? That you will know the trick that it needs basically the perfect sum approach. But still, I will guarantee that I can write and give you that you will not get the answer in your first go, okay? Because the question is the test cases are designed in such a way that your solution will not get accepted, okay? So let us quickly begin. Remember, this is a FAANG level interview question, so you are going to solve something really great. So have that time, have that patience. So then I'm sure that you will get something good to learn, okay? Let's quickly begin. It's 1524 number of subarrays with odd sum, okay? What we are given, so simply given a basic integer array. All the numbers are going to be positive. In this case they are going to up to 100. Remember, again, this is the trick here, okay? This number, if you see, it's a very less one, okay? Sometimes after happen, no, they will give 10 power 5 here also and 10 power 5 here also, okay? This time they have given 100 here. That is the trick, okay? That you have to see in my solution. Okay, let me do this. Today I will be showing three solutions, okay? I will remember, I will not be showing the brute force ones, okay? I will be starting itself from the optimized one, and then we'll keep optimizing it, and like that I will be showing you three solutions, and the third one is something that will be submitted, okay? That will like get submitted, okay? So the same thing I'm telling you, I got in from here, and based on this I have optimized that. I will show you how this works, okay? So the length of the input is going to be around 10.5, right? So what we have to do, we are simply given an array, okay? See, first thing is, I expect you to come and see this question once, okay? Take the link from the description, come and see this question, okay? I will not be like going through all the examples and all. My aim here is that I, in the minimum time, I give you the most efficient and valuable content, okay? That is my aim, right? Now see this, you are given a simple array. What you have to do, you have to generate all possible subarrays of this, okay? In the all possible, like among all the possible subarrays, find the subarrays whose sum of elements is odd, okay? And then record them. So ultimately we'll have to give us total number of sum, okay? That is total number of subarrays with the odd sum, okay? Let us see example number one. So these are the possible subarrays for example number one. Among them, if you see, I guess this one and this one, this one and this one, okay? So among them, only these four are returning, like are the subarrays whose sum is five, so whose sum is odd. For them, for that reason, we are counting them and we are returning the count, okay? That is the question. Let us quickly see how we can solve them. See, first thing is using a prefix sum approach. I am considering the length. I am doing a mod. I'm creating a prefix sum. The length is n plus 1 by c. The idea here is always I will keep the last element as 0. Okay, see, this is the prefix sum. Let me show how this works. Always the last element will be 0. Okay, see here. First element I will keep as it is, okay? Now the second element 3, what will you 3 will be added with the previous element 1, and that sum will be recorded here. Similarly 5 we will take, add it with the previous element, and we will record the sum here. 5 plus 4 is 9, we'll record it here. And always the last element will remain 0 by c. In Python, when you say arr of -1, okay, let us say a prefix sum of -1, then this element will be referred, okay? So -1th element is basically means the last element, okay? So in order to see the way I have written the code, no, say I'm doing this -1. So if you do 0 -1, basically you will get this particular element, okay? Because of this we'll be able to take the subarray of the first element, okay? That is the reason why I have kept the last element as 0, okay? That is the basic idea. You could have also done the way that in front of this you could have added element 0, okay? Something like that you could have also tried, but again, with that we'll have to shift the indexes and all that. But in my way, I felt like this will be really helpful and easy to show, okay? So I've done that. So what we are doing next, see, I will be going a bit fast, but my aim is like would have already saw, like tried this question, so you know the basic steps. That's why like I'm jumping a bit in a hurry for the basic steps, okay? So that I can spend some more time in the most optimal solutions, okay? Now this is how I'm filling the prefix sum array, okay? See, I'm creating a prefix sum of length n plus 1. I'm like for the 0th element, I take it directly from the arr, okay? Then for each of the other elements, generate the prefix sum and save it, okay? In this case, if you see, for the prefix sum, what we are doing, take the prefix sum of the previous element and add it with arr of it, okay? Right, then we are creating answer equal to 0, and then see, we are using two for loops. Why we need two for loops? See, the idea here is we want to generate every possible subarray, right? See, every possible subarray means it can start at, see, the subarray can start at any index and it can end at any index, okay? It can start at any index and it can end at any other index after that, okay? So that is the idea behind this. So I is going to be the starting point of the subarray and j is going to be the ending point of the subarray, okay? J will always be equal, greater than equal to I, okay? So I is the starting point, j will always be greater than equal to I, right? Now what we are doing, say I'm taking prefix sum of j, I'm subtracting that with prefix sum I minus 1, okay? So the way that I have defined, always the sum between I and j will be captured through this, okay? Because I'm doing I minus 1 and I starts from 0, that is the reason why I have kept the last element as 0, okay? That's why the reason I've kept this as a 0 element, okay? Right. Now, if you will get the subarray sum now, if the sum is odd, then you got the answer. You have to just do answer plus one. And finally, after all this loop completes, just return answer percentage mod. Okay. Now, these print statements are just for your help. So let us quickly see which all subarrays are like satisfying our constraint. See, the array with if you see this subarray, the sum is one, so it is odd. If you see this subarray, the sum is again odd. The sum is nine, which is odd. Similarly, this one and this one. Okay, these are the four arrays which are odd, and we are getting the answer. Okay, I have already segmented the solution after removing the print statement. Still, this was not getting accepted. Okay, so we'll need to optimize further. Where we can optimize further, see, now we'll go to the logic building phase. Okay, if you see here, this we are subtracting two numbers. Okay, in what, can you quickly tell me what will be the properties of these two numbers to ensure the subarray sum is odd? Okay, so we just need an odd subtraction. Okay, that is the result of the subtraction should be odd. How to ensure that? See, if this number is even and if this number is even, you will again get an even number. Okay, similarly, if this number is odd and if this number is odd, again subtraction between two odd numbers will again give you an even number. So how to get odd number? You will get odd number if any one of these two numbers is odd. Okay, the other one is even. I will again repeat, you will only get odd number when any one of these two is odd and the other one is even. Okay, any one can be odd, any one of them can be even. Okay, but remember, they should not be same. Okay, both of them should not be even. Similarly, both of them should not be odd. Okay, one of them should be odd, one of them should be even. Okay, if we can ensure that, then we'll automatically get the answer. Okay, so how to ensure that? See, this time, if let us go to my second solution now. This time I have done the changes. Okay, this time using the bit manipulation part. Okay, what I'm doing, see, after I generate the prefix sum, now what I'm doing is, see, I will just show you the output quickly. See, let me open both the outputs and then I can show you for example one. Yep. See, this is the prefix sum for example one, right? Now, remember, same thing, zero always will be there at the last, same thing. But wherever you are seeing even number, that will be replaced with a zero, and wherever you are seeing odd number, that will be replaced with a one. Okay. Same thing I'm doing here. See, same thing. Okay. Same thing now. See, 1 is odd. Okay. 4 is even. 9 is odd. 0 is even. Okay. So odd, even, odd, even. Similarly, if you see a same thing, 1 is for odd, 0 is for even. So odd, even, odd, even. Okay. What I did in the prefix sum, basically, wherever even numbers were coming, I replaced them with a 0. Wherever odd numbers were coming, I replaced them with a 1. Okay. That's what I'm doing it. Why I did that? Because as I mentioned in this part, no, we just need to bother about whether the prefix sum, that the prefix sum basically is odd or even. Okay. We just need that info. Okay. We don't need the actual big numbers, because if you see what is happening, we need to subtract such a big numbers. Okay, definitely there is a lot of time getting used for that. Similarly, we have to again divide a big number, which again some time is going for that. So we don't want to go into all these things. Okay, what we did is, this time, yeah, this is where this point comes into picture. See, it's very easy to divide and check for a single element rather than a prefix sum element. Okay, it's very easy to check for a single element if it is odd or even. Okay, that's what we're doing here. If you see what I'm doing, see, prefix sum is already calculated. Okay, so what we're doing, for the ARR of 0, we are passing it to this particular function. This function will return as 0 if it is even and 1 if it is odd. Okay, the same thing what we're doing. Okay, now prefix sum of I minus 1 will always be a binary. Okay, either it is 0 or 1. Okay, now for ARR 5, we just need to decide if it is odd or even. Since ARR 5 can be up to 100, that is the why we are using this logic now. See, it is easier to divide a number which is small than a number which is really big. Okay, so when it is smaller, that time itself we are dividing it by 2 and we are checking whether it is odd or even, and based on that, we are deciding whether the prefix sum I is going to be odd or even. Okay, remember, we are doing XOR operation here. Again, the property of XOR, if I am assuming you should be knowing that if, let us say, if these two numbers are having different values. Okay, for example, this is the odd one, this is the even one. That is, let us say, this is first number, this is the second number. Okay, now if both of them are even, then XOR will be 0. Similarly, if both of them are odd, XOR will be 0. But if one of them is odd and the other one is even, then XOR will be 1. Okay, so prefix sum of I will be basically 1 if it is odd number, and it will be 0 if it is even number. Okay, now how are we using this fact? Now, same thing, two follow-ups I'm using. This time, instead of subtracting, see, here we were subtracting them. Okay, here we're subtracting them. After subtraction, the result, we were dividing it by 2 to check if it is odd or not. This time what we are doing is, we will not do anything like that. We will simply do a XOR. Okay, if they are different, that is, if one of them is even, one of them is odd, the XOR result will automatically be 1. Okay, and that result will be added to our answer. Okay, let us say both of them are even, or let us say both of them are odd. In either of the cases, this result will be giving us a 0. Okay, so 0 will be added to the answer. See, adding 0 obviously doesn't make sense, right? So adding 0 will not change the answer at all. Okay, only so what will happen? See, only the subarrays, okay, that's only the prefix sums which are like the forming combination of odd and even, only they will be contributing to the answer now. Okay, so what is happening is, if one of them is odd and one of them is even, only then their XOR will be resulting into 1, and only then it will be contributing to the answer. Okay, and finally we are doing answer percentage mod and we are getting the answer. Okay, so let me summarize what the optimization we did. See, here we were basically doing subtraction. Remember, these values could be very very high, because remember, they are sums. Okay, they will not be like this. Okay, they will not be just 100, they will be really big. Okay, because see, 10 power 5 elements are adding. Let us say there are hundreds, 10 power 500s. We are adding all of them. So last element will be obviously very huge. That we are subtracting with a smaller element. So obviously result will still be bigger. Okay. That bigger number we are dividing by 2. Obviously that will take a huge time, right? Dividing such a big number by 2 will definitely take a really lot of time, right? So instead what we are doing is, instead of doing all that stuff, what we are doing now is, when they are small, that time itself we'll divide and check if we are odd and even, and accordingly we'll form our prefix sum I. Okay, prefix sum I will only store binaries like this. If you see, this is the prefix sum. Okay, this time it will only store the even, that odd and even results. Okay, and that is the reason why when you see here, what we are doing is, at the final step between these two for loops, what we are doing is, we are just checking whether the starting of the previously we were subtracting, right? Prefix sum of j minus prefix sum I minus 1, all that we were doing. This time what we will do is, instead of subtracting, we are just taking XOR. Okay, this is to ensure that, see here, the requirement was, if one of them is even and one of them is odd, then we will get our answer. Then that will contribute over to our answer. Same thing we are doing here. If one of them is even, one of them is odd, then that will contribute to our answer. That means the XOR result will return 1, and that we are adding to the answer. Okay, and finally we're doing answer of percentage mod. I hope you are clear with the solution now. Okay, so this solution is really great, but again, this will also not get accepted, unfortunately. Okay, so we'll have to optimize even further. Now, how to optimize further? For that reason, we'll now have to see what we have done and what we can do better. See here now, let us analyze what we have done now. Okay, see, this is the one. Okay, this one, if it can be paired with a 0, it will give us the answer. Okay, let us see how many zeros are there and how many zeros it can be paired with. Okay, this one can be paired with the remaining two zeros. Okay, there are two zeros, with both of them it can be paired. Okay, similarly, this one can also be paired with both the zeros. Okay, so there are two zeros and there are two ones, so each one can be paired with both zeros. So totally we can get 2 into 2, 4 pairs. Okay, that is why our result is coming as 4. Okay, let us try to form the same logic after this only. So yep, in this case there are no ones. Okay, so we cannot pair it with, see, here zeros are there, but they cannot be paired with a 1. Okay, so that is the reason why we are not getting any answer right now. Let us go to a better case. See here, how many ones are there? Here there are 4 ones. Okay, how many zeros are there? Here there are 4 zeros. So like, try to take one step at a time. See, each one can be paired with 4 zeros. See, each one can be paired with either of the, any of the 4 zeros. Okay, each one can be paired with any of the 4 zeros. Okay, now for one, that is for a single one, we can form 4 pairs. Okay, with a single one we can form 4 pairs by pairing them with any one of the zeros. Okay, similarly, how many ones are there? There are 4 ones, so it is going to 4 into 4. There are 16 pairs possible, which are going to give, that is total 16 subarrays are possible, which will be giving us an odd sum. Okay, that is the reason why we are writing 16. Okay, let us take a better case now. Okay, let us take somewhat better case now. This is a very random case I have taken. See, in this case there are again 4 ones, but there are 5 zeros. Okay, that is each one can form basically 5 pairs, because there are 5 zeros. Similarly, there are 4 ones, so how many total pairs can you form? It is going to 5 into 4. So if you see the logic how it is coming, the answer is always the number of ones multiplied with the number of zeros in the perfect sum array. Okay, in the perfect sum, the answer is like, how to generate the answer is going to be number of ones multiplied with number of zeros. Okay, in this case there are 4 ones and there are 5 zeros, so 5 into 4 is 20 is the answer. Okay, so that is the logic we have to build now. Okay, so we don't need to go by this, two for loops and doing all this XOR and all. We don't need to do all that. We just need to know how many ones are there and how many zeros are there in our prefix sum. Remember, again, I will say one thing. This last zero is something that I've added on my own. Okay, you will not get this. Okay, you will have to add it additionally. If you see in my, like, the first code, I'm taking this as n plus 1. Okay, and then I'm making all the elements as 0. From there it is coming. Okay, from there it is coming right now. That's why I'm mentioning this zero is coming on my, like, with my code. Okay, it's, if you do the same thing, you will not get this. Okay, so you'll have to add this additionally right now. You have to just count number of ones and you have to multiply them with number of zeros, and then you will get the answer. Okay, so we don't need all this for loops and all. Okay, we don't need these two for loops. We can just at this step itself, when we are calculating the prefix sum of I, basically, okay, at this step itself we can just record how many ones are coming and how many zeros are coming, and that is what we are going to do in our final solution. Okay, this solution is a final solution that will get accepted. See what we are doing. Everything remains the same. Okay, everything remains the same. Only thing is, this is the additional thing that we are creating. Okay, see here I'm just recording the frequencies. So this is the key one. Key will tell me which value I'm trying to record, and see, the value is going to be its frequency. Okay, now for 0, I have kept the frequency as 1 at the starting itself. Why? As I mentioned, this, if you see, I have given n plus 1, and always there will be last 0. Okay, this 0 will be there always at the last. Okay, that is the reason why I'm recording it in the starting itself. Okay, because if you see, in this, yep, at this particular stage, prefix sum y, this will not be calculated. If you see, it will go till n minus 1 only. Okay, it will not go for n. Okay, that is the reason why prefix sum y will not be calculated for this last 0. Okay, this last 0, where is it? Okay, this, for this last 0, basically, prefix sum y is not getting calculated. For that reason, its frequency I am directly adding at this stage itself. Okay, at this stage itself I'm directly adding its frequency by 1. Okay, the 0 is starting with 1 and 1 is starting with 0. Okay, as simple as that. Okay, this will record number of odds and evens in the prefix sums. Okay, now everything else remains the same. Okay, I'm only doing this thing, that yeah, for the prefix sum of 0, I'm look taking this value, and I'm just checking if it is odd or even. If it is odd, no, like, reduce it to 1. If it is 0, sorry, if it is even, reduce it to 0. Okay, I'm just checking if it is 0 or 1. Accordingly, I'm just incrementing its frequency. Okay, same thing I'm doing it here. Okay, this is coming from your solution number 2. I'm doing XOR here. Okay, I'm taking the previous prefix sum of I. Okay, that is the prefix sum of the last element, and for the current element there is error of I. I'm just checking if it is odd or even, and for these two I'm doing the XOR. Okay, now this XOR result will be stored here, and based on if it is 1 or 0, we will increment the frequency accordingly. Okay, fine. So I will be printing these two, and at last see what we are doing. I'm just multiplying the total number of ones we have seen and the total number of zeros we have seen. I'm just multiplying these two, and I'm doing a percentage mod. Okay, if you see the output, let us go by example number 1. Okay, yep, in this case there are two ones and there are two zeros. Okay, so answer is going to be 2 into 4. For example number 2, there are going to be 0 fours. Okay, sorry, there are going to be 4 zeros, but there are no ones. Okay, so 0 into 4 is equal to 0 is your answer, right? Let us go to example number 3. In this case, the number of ones is 4, the number of zeros is 4, so 4 into 4, answer is 16. Okay, this is what we have to do. So this is going to be a final solution where you're multiplying the number of ones with the number of zeros, and at last we are doing just percentage modulo, because that is the requirement of the question, and then we are getting the answer. So this is the final solution. You should submit it by commenting all these print statements, and then your solution will get accepted. Okay, this, see the beauty of this question. We started already with optimal solution. See, remember, this solution that I'm showing you, that is solution number 1, the prefix sum. Okay, this is not a brute force solution. Okay, this is also optimal solution. If you go with the actual brute force solution, let us see what will happen. So you will have, okay, you will have two for loops, and you will see after these two for loops you need additional for loop to like go take the sum of each of the elements in the subarray. Okay, you need these two for loops to mark the start and end of the subarray, and after that we need an additional for loop to basically take the sum of the elements. So that would have been the brute force approach. Okay, that would be around O of n cube. Okay, but in this we are just reducing it to two for loops. Okay, in the solution 2 also we are reducing it to two for loops, and in the final solution, if you see, we do not have a for loop at all. Only at this stage we have a for loop. Okay, only at this stage. So if you see, this is going to be O of n solution. Okay, and space wise also is going to offline solution. Again, I will repeat with the optimization that we have done. See, the number is going to be really small. Okay, at the starting, that's why in the starting scenario itself we are dividing it by 2 and knowing it whether it's odd or even. Okay, that is the best part that we are doing. Okay, because once it becomes 10 power 5 and all, dividing it by 2 will also take a lot of time. Okay, that is also a big computation task, right? And doing that for so many numbers, it definitely a really big computation task. Okay, so we are reducing that. When it's small, that time itself we are recording it whether it's odd or even. Okay, at last we have to just multiply these two numbers, and we have to take the model, and we are getting the answer. So this was the final solution, friends, and I hope you enjoyed the whole process. I showed you from, see, the first solution itself, as I mentioned again and again, I'm mentioning this is not a brute force solution. This is again optimal solution only, but still this was not getting accepted. So I modified this part. Okay, instead of doing this subtraction and taking the value and dividing by 2 to get odd or even, instead of doing that, I introduced the concept of the XOR. Okay, I am now reducing it to XOR. Okay, I will only record if it is even or odd, and during the subtraction that would be helping me. Okay, is it is helping me to know whether the subtraction result will be odd or even. Okay, because of this I'm getting the help. Okay, by reducing it to odd and bits, that is binary, I'm getting that help. Okay, this is XOR, by the way, right? This is also XOR, this is also XOR. Even this was not accepted. So what I did is I finally observed, and I noted that it final result depends on the number of ones and the number of zeros. Remember, the one additional zero I'm always inserting because I've taken n plus 1 here. Remember that part. This you will get confused if you are not seeing this video properly. Okay, and finally we are doing the mod and we're getting the answer. So yeah, fun, that was all for this video. See, as I mentioned, will give these three codes. Okay, I will mention that it's the solution 1, solution 2, and solution 3. Solution 3 will be the most optimal. Okay, so I will be giving them in the comment section. Take them, try to understand what is happening. See, you see, many of you will say that, okay, I'm saying this very fast, but see, my aim here is not to spoon feed you the solution. That is not at all my aim. My aim is to build that logic in you. Okay, that my always aim is to go for the logic building. Okay, rather than spoon feeding the solution. That is why I'm going a bit fast, because I want to cover so much topic in a single video. Because see, always my aim is to get some quality content to those people who cannot afford paid courses. That is always my aim. That is why within a short span I have to give so much information, right? That is the reason why sometimes I have to speak very fast, and obviously the video lengths are also like that. Okay, so please don't take it in a negative way, take it in a positive way. You have the content in a single video. Okay, maybe like you can reduce the speed, you can like rewind and again come back, and you can do all that stuff, right? Always remember, my aim is to give you the quality content in a small video. Okay, so I try to give everything whatever is possible from end, and try to give everything. Okay, like, but it's up to you. You can see, make the playback speed a bit small, like lesser, or maybe you can remind and see again the part that you're not clear to. But again, like, it's all about your hard work. Okay, these solutions, I'm assuming that you have already tried the question, then you are coming and seeking the solution. Okay, otherwise it will not be easy for you to teach everything from scratch. Okay, that would take a really lot of time. Remember, this is a FAANG level question. So again, please do not expect a spoon feeding for this kind of questions. Okay, this is actually very easy to solve in a brute force, but the thing is, it will not get accepted. That is the final thing, right? Your solution will not be accepted. Okay, you have to keep optimizing, and then you will reach this kind of solution. So I try to show you the whole thing that you would have done if this would have been a FAANG level interview question. What you have to do, you have to first design this kind of approach, which is obviously not a brute force but slightly above brute force, and then keep optimizing till your solution gets accepted. Okay, this is often solution, both often in time and space complexity. So often, that was all for this video. If you like my efforts, please do subscribe to the channel. This really gives a lot of motivation to continue further. Our aim is to create quality content videos for those people who cannot afford paid courses. That is our aim, and that's what we are striving to work for. See you tomorrow. Thanks a lot. This was my 126th day of continuous late coding. There are many more days to come for sure. See you tomorrow. Thanks a lot.